Good morning, all of you.
Good morning, sir.
So today we are going to discuss fourth chapter, that is composition of forces. I told you earlier that the resolution and composition both are opposite words. Resolution of force means splitting a given force into two or more parts so that the effect of that force remains same. And those parts are known as components of force. Whereas composition of forces, if number of forces are acting on a body, then if you combine all the forces to get a single force, or if number of moments are acting, if you combine all the moments to get a single moment, that single force or single moment is known as resultant. Right? Simply, determination of resultant is nothing but composition of forces. Right? Then how do you define resultant? Resultant can be defined as a force or moment which can replace the given system of forces or moments without changing the effect. Is it clear? So here determination of resultant is composition of forces. We are going to study basically coplanar force system. Again, in coplanar force system, we are going to find out the resultant of concurrent force system, parallel force system, and general force system. Means non-concurrent, non-parallel force system, that is general force system. So in concurrent force system, we'll find out the resultant when only two forces are acting. When two concurrent forces are acting, how do you find out the resultant? When more than two forces are acting, how do you find out the resultant? So when two forces are acting, we can find out the resultant either by using triangle law of forces or parallelogram law of forces or by resolving each force into x and y components. X and y components. When more than two forces are acting, more than two concurrent forces are acting, we can find out the resultant either by using polygon law of forces or again by resolving each force into x and y components. Please note down parallel force system, general force system, that we will see later. So we are going to discuss in detail about the determination of resultant for coplanar concurrent force system. So now, note down the statement of triangle law of forces. You have already learned the triangle law of forces and parallelogram law of forces in physics. if I am not wrong. So write down the statement. When two coplanar concurrent forces, when two coplanar concurrent forces are acting simultaneously on a rigid body, are acting simultaneously on a rigid body, which are represented in magnitude and direction by the two adjacent sides of a triangle, then the resultant of those forces, is represented in magnitude and direction by the third side of the triangle, taken in the opposite direction, taken in the opposite order. Please see this figure. So there are two concurrent forces P and Q are acting at point O. Let theta be the angle between the two forces. As per triangle law of forces, these two concurrent forces are represented in magnitude and direction by the two adjacent sides of a triangle taken in order. So it is force P, then in continuation force Q. Then the resultant of these two forces is represented by the third side of the triangle taken in the opposite order. See, this is our usual order, right? But the resultant is to be taken, the third side is to be taken in the opposite order, in magnitude as well as direction. Say alpha with respect to force P. So now R is the resultant, making an angle alpha with force P. So that is triangle law of forces. Now either knowing force P, magnitudes of force P and Q and the angle between them, either by using cosine rule or by using sine rule for this triangle, you can find out the magnitude and the direction of the resultant force. How much is this angle? Angle made by Q with respect to P is theta. So this internal angle 180 minus theta. Then you have this third angle. See, it is 180 minus alpha minus of 180 minus theta. That gives you 180 gets cancelled, theta minus alpha. Now what is the cosine rule? Suppose if we say this is O AB. Cosine rule says OB square is equal to OA square plus AB square minus 2 into OA into AB cos A. Cos A means that is 180 minus theta. So this is nothing but R square is equal to P square plus Q square minus 2PQ cos A. So knowing PQ and this angle, you can find out the magnitude of resultant. To find out the direction of resultant, you can use sine rule, that is AB upon sine of opposite angle, that is alpha, is equal to R upon sine 180 minus theta, or is equal to OA upon sine theta minus alpha. So from this you can find out the direction of resultant. Parallelogram law of forces. Parallelogram law of forces. When two coplanar concurrent forces, are acting simultaneously at a point, on a body, which are represented in magnitude and direction by the two adjacent sides of a parallelogram, then the resultant of those forces represented in magnitude and direction by the diagonal of the parallelogram passing through the point of intersection.
So can you repeat?
When two coplanar concurrent forces are acting simultaneously at a point on a rigid body, which are represented in magnitude and direction by the two adjacent sides of a parallelogram, then the resultant of those forces is represented in magnitude and direction by the diagonal of the parallelogram passing through the point of intersection of those forces. See this figure. There are two concurrent forces P and Q acting in point O, which are represented by the adjacent sides of a parallelogram, say OA and OB. So by drawing lines parallel to this, you can construct the parallelogram. Then the resultant of these two forces is represented in magnitude and direction by the diagonal of the parallelogram passing through the point of intersection. So the direction of resultant with respect to P is alpha. Let us say this is C. Then now we have parallelogram OACB. P is represented by the side OA, Q is represented by the side OB, and the diagonal OC gives you the resultant. Theta is the angle between P and Q, and alpha is the angle made by the resultant with respect to force P. Now we have OB is equal to AC. So this is nothing but Q. Let us draw a perpendicular from point C on the line OA. Now determine how much is this angle? Angle made by Q with respect to P is
Theta.
theta. Now from this right angle triangle, let us say this is D. Right angle triangle ABC. How much is this side in terms of theta? For this right angle triangle is the adjacent side. So you can write it is Q
cos theta.
Cos
Q cos theta.
right. So the opposite side Q sin theta. Whereas you have this OA as P. Now, from the right angled triangle ODC, right angle triangle ODC, we have this as R. This angle is alpha. Now, from Pythagoras theorem, OC square is equal to OD square plus CD square. OC is nothing but R. R square is equal to OD square, that is OA plus AD, P plus Q cos theta. P plus Q cos theta whole square plus CD square, that is Q sin theta whole square. So we have R square is equal to P square plus Q square cos square theta plus 2PQ cos theta A plus B whole square plus Q square sin square theta, right? So Q square sin square theta plus Q square cos square theta is equal to Q square. So it is P square plus Q square plus 2PQ cos theta. So the magnitude of resultant is given by square root of P square plus Q square plus 2PQ cos theta. So by using this expression, you can calculate the magnitude of resultant. Okay. Now how do you find out the direction of resultant alpha? from the same right angle triangle ODC, tan alpha is equal to opposite side CD upon adjacent side OD, but CD is equal to Q sin theta. OD is OA plus AD, P plus Q cos theta. So this gives you direction of resultant alpha is equal to tan inverse Q sin theta upon P plus Q cos theta. Now you tell me, this angle alpha is with respect to which axis? This direction of resultant alpha is with respect to. You should not say that it is x-axis. This is yes, with respect to force P. Not necessarily force P is along x-axis. Right? Suppose if you have this as force P, force Q, then the resultant is R, making an angle alpha with respect to force P, not with respect to horizontal or x-axis. Point to be noted. The angle made by the resultant with respect to force P. Suppose if you consider this as P and this force as Q, then alpha is the angle between this R and this force P. Remember, the notations are very important. So it is always with respect to force P. Now, say case 1, when theta is equal to 0 degrees. What is theta? Angle between P and Q. When theta is equal to 0, that means force P and Q are collinear. So both are collinear. Now what is cos theta? That is cos 0. Yes?
1.
1. So magnitude of resultant R is equal to square root of P square plus Q square plus 2PQ cos theta. Cos theta is 1.
R is equal to P plus Q.
Right. P square plus Q square plus 2PQ. So R is equal to P plus Q. Theta is 0 means both are collinear acting in the same direction. Therefore R is equal to P plus Q. Case 2. When theta is equal to 90 degrees, that means force P and Q are perpendicular. Now what is cos theta? Cos 90 is 0. Then the magnitude of resultant R is equal to square root of P square plus Q square. Now case 3. When theta is equal to 180 degrees. So here both P and Q are collinear. They are acting around the same line, but in the opposite direction. Right? Now what is cos theta?
-1.
Cos 180 is -1. Therefore, R is equal to square
P
root of
minus Q.
right, P square plus Q square minus 2PQ. So that is P minus Q. So it is P minus Q or Q minus P. It depends on the magnitudes of force P and Q. And the resultant will always act in the direction of greater force. Concurrent forces are acting. The third method is by resolving each force into X and Y components. You can find out the resultant. Suppose the two concurrent forces, force P and Q, are acting at point O. So the angle made by P with respect to x-axis is theta 1. The angle made by Q with respect to x-axis is theta 2. Now to find out the resultant. See, from this theta 1, theta 2, you can find out the angle between the two forces. So either by using triangle law or parallelogram law, you can find out the magnitude and direction of resultant. But sometimes it is convenient for us to resolve the force into perpendicular components. So here, by resolving force P into X and Y components, we have this as Px, Py. Similarly, force Q, Qx, Qy. Now, taking algebraic sum of all X components of the forces, X components of the two forces. So we have Px minus Qx. Now, what is this algebraic sum of X components of the forces? Is nothing but X component of resultant. Am I right? Simply resultant is nothing but algebraic sum of all the forces is the resultant force. I am taking algebraic sum of all X components of the forces. So X component of resultant. Similarly, by taking algebraic sum of the Y components, say Py plus Qy, it is nothing but Y component of resultant. Now for the resultant, we know the X and the Y components. Say this is Rx, Ry. Now say this case, second case, when the forces P and Q are acting perpendicular to each other, the resultant of those two forces, we can find out square root of P square plus Q square. Similarly, here this Rx and Ry are the components of R. So to find out the resultant, R is equal to square root of Rx square plus Ry square. Is there? That means R is equal to square root of summation fx square plus summation fy square. Now to find out the direction of resultant, say alpha with respect to x-axis, with respect to rx. Now we have this as ry, this vertical side. Now tan alpha is equal to ry upon rx. That is summation fy upon summation fx. Therefore, alpha is equal to tan inverse summation fy upon summation fx. Now you tell me, this is with respect to
X-axis.
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 This with respect to x-axis, nothing to do with respect to p. This is always with respect to x-axis. So first step is you have to resolve each force into xy components. Second step, you take algebraic sum of x components and algebraic sum of y components. Third step, magnitude of resultant you can find out by square root of summation fx square plus summation fy square. Direction of resultant you can find out tan inverse summation fy upon summation fx with respect to x-axis. But to define the force or the resultant force completely, we must know its four characteristics. Magnitude of resultant, that you can get from this. Direction of resultant, that you can get from this. Point of application of resultant and sense. So how do you find out these two? Sense you can find out from the signs of summation fx and summation fy. For example, if you get summation fx, summation fy, both are positive. That means the resultant is in the first quadrant. Summation fx negative, fy positive. Second quadrant. Both are negative. Third quadrant. X positive, y negative. Fourth quadrant. That gives you the sense. Now you tell me, how do you find out the point of application of resultant? Where it will act for concurrent force system? Anybody?
So it will act at the same point at which from which P and Q are originated.
Point of
Why?
intersection.
Why it is so? Why it will act at point O? Why not somewhere? That is true. Resultant will act at the point of concurrence. But why?
Because resultant is generated because of that two forces
Resultant is
generated from that two forces.
The resultant has to give the combined effect of P and Q only, no? So the resultant will act at point O.
okay. Suppose this is force P, Q acting at point O. Let us assume that the resultant of these P and Q are acting somewhere in the plane. We don't know, somewhere it is acting. Now we have to find out where it is acting. Say it is acting at a perpendicular distance D from point O. Now see, R is the resultant of P and Q. As per Berigna's theorem, algebraic sum of the moments of the forces about any point is equal to moment of resultant about the same point. About any point. Why not point O? Are you getting me? So taking algebraic sum of the moments of both the forces about point O, you will get it as 0.
0.
The lines of action of these two forces are passing through point O. So as per Berigna's theorem, this algebraic sum of the moments of the forces about point O is equal to moment of resultant about the same point, that is R into D. Moment of resultant R into D. So R into D is equal to 0, but R is not equal to 0. It is having some magnitude. Therefore, D has to be 0. D is 0 means the line of action of resultant is passing through point O. So for concurrent force system, resultant will act at the point of concurrence. Okay? Next part. Now all these three methods are used when two concurrent forces are acting. Now when more than two concurrent forces are acting, we have two methods, out of which one is this general method, resolving each force into xy components and finding the resultant, and the particular method or graphical method is polygon law of forces. Polygon law of forces. Note down the statement. It states that when number of coplanar concurrent forces, a number of coplanar concurrent forces are acting simultaneously, at a point on a body, which are represented in magnitude and direction by the adjacent sides of a polygon, taken in order, then the resultant of those forces is represented in magnitude and direction by the closing side of the polygon, taken in the opposite order. Draw this figure. Here four concurrent forces are acting at point O, F1, F2, F3, F4. See, polygon law of forces is an extension of triangle law. Triangle law is used for only two forces, whereas polygon law more than two forces. So as per polygon law of forces, these concurrent forces are represented in magnitude and direction by the adjacent sides of a polygon taken in order. So it is F1, F2, F3, F4. Then the resultant of these forces is represented in magnitude and direction by the closing side of the polygon taken in the opposite order. So our usual order is anti-clockwise, but the resultant is to be taken in closing side clockwise. So the length of this side gives you the magnitude of resultant, and the direction of this side with respect to say F1 gives you the direction of resultant. So it is graphical method. You can solve it by plotting, by selecting suitable scale for the magnitudes of these forces. You can plot the figure. By measuring the closing side, you will get the magnitude, and by measuring the angle of that side, you will get the direction of resultant. Okay. Suppose the given system is in equilibrium. If the given system is in equilibrium, then you can say that the resultant is 0. Which means that the starting point of the polygon and the end point of the polygon must be the same. Is it clear? So when the system is in equilibrium, you will get a closed polygon. So there is no open polygon. Any doubts? Please note down the example statement. Two forces of magnitude 300 Newton and 200 Newton are acting at point O as shown. Determine the magnitude and direction of the resultant using triangle law of forces, parallelogram law of forces, and by resolving each force into x and y components. So first, we'll use triangle law of forces. So in triangle law of forces, we will represent these two forces by the adjacent sides of a triangle taken in order. So it is 300 Newton, 200. Then the closing side of the triangle taken in the opposite order gives you the resultant. Let us say the direction of resultant with respect to 300 Newton force is alpha. And it is given that the angle made by 200 with respect to 300 is 40. So we have this internal angle 180 minus 40, 140. So we have this angle as 40 minus alpha. Now for this triangle, I will use sine rule. So as per the sine rule, it is 200 upon sine of opposite angle, that is alpha, is equal to 300 upon sine of opposite angle, that is 40 minus alpha, is equal to r upon sine of 140. So solving these two terms, you can get angle alpha, and by making use of the third term, you can get r. Or even to find out the magnitude of resultant, you can use the cosine rule. As per the cosine rule, it will be r square is equal to 300 square plus 200 square minus 2 into 300 into 200 cos 140.
R equals to 471.
R is equal to how much?
471.
Right.
471.06.
471.089. .84. This is with respect to 300 Newton. With respect to the force, 300 Newton. Okay. Then we use parallelogram law of forces. So I am considering 300 Newton as force P, 200 Newton as force Q, angle between them is theta, that is 40. So the magnitude of resultant is given by, as per parallelogram law of forces, square root of P square plus Q square plus 2PQ cos theta. Direction is given by tan inverse Q sin theta upon P plus Q cos theta. You are going to get the same answers with a small difference, that is rounding errors. 471.
Alpha is 16 degree.
Alpha is how much?
16 degree.
16. Okay. That difference is considered. This is again with respect to force P, that is 300 Newton force. Now the third method is resolving each force into x and y components. Here I am going to consider x-axis along 300 Newton force. Not necessarily 300 is horizontal, remember. But I am taking x-axis along 300 and the y-axis is perpendicular to it. So if you resolve this 200 Newton force, you have this is x component, y component, making 40 with x. Now here 300 Newton is acting along x-axis. So what is the x component of 300 Newton force?
300 Newton.
300 Newton, right. Now taking algebraic sum of x components of both the forces. X component of 300 is 300 itself. You can say 300 cos theta, whereas theta is 0. And what is x component of 200 Newton force? It is plus 200 cos 40. Now algebraic sum of y components of the forces. What is y component of 300? 0. It is acting along x-axis, its y component sin theta, theta is 0. And y component of 200 plus 200 sin 40. Then you get magnitude of resultant, square root of summation f x square plus summation Fy square. Direction of resultant tan inverse summation Fy upon summation Fx. This is with respect to x. That means with respect to 300 Newton force. Again, you are going to get it as 471.089, 15.8. This is 453.21. Summation Fx. Summation Fy is 128.56. Okay. Thank you. We will see in the next class.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.